Hi guys, good afternoon. So today let's start with the ASA firewall. Yesterday in the last session we have seen about the evolution from router to PIX to ASA to FTD, NGIPS, all that. Now today we'll start with the ASA firewall. So if we talk about ASA, ASA is a very basic firewall. Okay, your ASA is a very basic firewall. Okay, it performs the filtering based on layer 3 and layer 4. So now first of all we'll understand the basics of your ASA. Okay, and then we will go towards the further concept, towards the configurational part. So today we'll also set up the lab. Okay, our ASA lab we are going to set up. About ASA, general introduction that your ASA stands for Adaptive Security Appliance. Okay, and this is a piece of networks security hardware that is sold by Cisco, and they are multi-purpose security devices. So they have your firewall, antivirus, IPS, and VPN capabilities. So not ASA. This is about a general firewall, that whatever the firewall Cisco is providing. So these features, your antivirus, IDS features, okay, intrusion prevention features, these are available in the FTD, not in the ASA. Okay, and the operating system it is running is what? The Cisco IOS. Okay, then see the Cisco IOS, it is running in the ASA only. Okay, this is for the ASA only. If you are using FTD, then you are using FXOS. Okay, FTD has a different operating system. Now, a little bit about history. So in last session, we have seen that your PIX, it was introduced in the year around 1994. Okay. Then in the year 2005, your ASA came up. And once ASA was out, so your PIX was announced end of sale in the year 2008. Okay. Now with the PIX, there was an issue that your PIX didn't have the VPN capabilities and all. So for VPN and IPS feature, we were using dedicated devices like VPN 3000 and IPS 4200 series. So these are the dedicated devices we were using. Later on, Cisco introduced ASA, and in the ASA, it combined your PIX as well as the VPN capabilities. So your ASA has a VPN capability also. Then these are some of the models of your Cisco ASA. So we have 5505, 5510, 5515X, 5520, 5525, 4050, 55, and 85. Okay, all these are different models of the ASA. Now, different models means different specifications they have, and the ones with the X, okay, the ones with the -X, these series. Okay, so these are the firewalls, these are the ASA firewalls, which can be upgraded to the FTD also. Okay, you can upgrade them to FTD. And these ones which are not the X series, these ones you cannot upgrade to the FTD. Okay. So if we talk about the specifications, so just in the coming slides it will be there, I believe. Yeah, see here. Okay, or else we can just go and check the data sheet also. There also we can be, it is going to be there. Okay, so if I open here, let's say ASA data sheet. Okay, so different models are there. This is 5500. So in each series you can see there are different models, that we have 5506, 5508, 5516, and they have different capabilities, like firewalling is what, 750 Mbps, 1 Gbps, 1.8. So this kind of differences will be there between the firewalls. Okay, and again there are some other features available, and all the X series is they can be upgraded to the your FTD also. So ASA models, the choice of model will depend on the organization's requirement, like what are the requirements, and the biggest difference between these models are what? Maximum traffic throughput, what are the different interface type, might be having gigabit or 10 gigabit or fast Ethernet, okay, and the number of interfaces as well as their cost. Okay, these are the major differences between these models. Okay, So depending on, what is the requirement of the organization, they will see that, okay, what is their throughput, what are the interface types required, what is the number of interfaces required. So accordingly, the organizations, they will select a firewall. Okay. Now these are the key features, your packet filtering. Okay. That means layer 3 filtering can be done, stateful filtering. So stateful filtering means your ASA is capable of maintaining the state table. Okay. Your ASA is capable of maintaining the connection table. Okay. So with the help of connection table entries, your ASA can allow the replies. Okay, it will maintain the state of connection, and based on that state, connection state, it will allow the replies. Then routing support is there. So yes, it can be used as a edge device. Okay, your ASA firewall can be used as a edge device because it can perform routing. Then transparent firewall concept is there. So what is this transparent firewall concept? That you can deploy your ASA firewall as a L2. Okay, AAA support is there. You can configure AAA in the ASA. Okay, centralized authentication can be configured. Then VPN support is there. You can configure VPNs. Virtualization concept is also there. Okay, virtualization means what? Guys, anybody aware about virtualization? What is virtualization? Yes, guys, anyone?
It can be run on any ESXi or like maybe it can be containerized kind of.
So basically, what is virtualization? Virtualization is the ability of a system to run multiple OSs, okay, on a single hardware. So in ASA, what does it mean? That means on a single physical ASA, okay, one single physical ASA, you can convert it into multiple logical ASAs. Okay, we can convert it into multiple logical ASAs, which we call it as a security context. Okay, that means in one single hardware firewall, we can create multiple virtual firewalls, and all those virtual firewalls will work as a dedicated firewall. Okay, all the traffics, okay, like all the policies and everything will be dedicatedly separate for each one. Okay, and the traffics, they will not merge. Traffic will be completely segregated. So whatever the number of virtual firewalls you will create, so all those firewalls will work as a separate firewall only. Okay. Then your ASA supports IPv6 also. VPN load balancing feature is there. Stateful failover feature is there. Okay. So stateful failover, we will talk about here the HA concept, in which we will go through device failure or device failure. We will go through interface failure. Okay. In the device, we will talk about, active and standby concept, active and active concept. And in the interface, we will go with the LAN side failure as well as the WAN side failure. Then we have clustering. So here what we did, you have one single ASA box. This is one single ASA box. And in this ASA box, you have created multiple ASAs. That means one ASA I have divided into ASA1 and ASA2. So eventually this is one firewall only, but it will start behaving like a two firewalls. Okay. So here we divide one firewall into multiple logical firewalls, but here in case of clustering, you will combine multiple physical firewalls into single logical firewall. That is your clustering. So clustering, you can consider like it's a reverse of your security context or virtualization. Okay. So in the clustering, we will combine the firewalls and MPF, where with the help of which your ASA will perform DPI, deep packet inspection. Okay. So these are some of the key features of your ASA firewall. Now, hardware integration module. So as per your requirement, see your ASA by default, it performs what? L3, L4 filtering only. That means filtering based on source IP, destination IP, source port and destination port only, as well as protocol and port number. So if you want that, okay, intrusion prevention feature should be there, layer 7 inspection should be there. So what you can do, you can use modules like SSM or SSC. So these are what? SSM stands for Security Service Module. This stands for Security Service Card. Okay. So these are what IPS modules in Advanced Inspection and Prevention Security modules. Okay. So kind of, if you want to perform layer 7, advanced inspection. So in that case, you can use these kind of modules. You can attach these kind of extra modules and you can perform the inspection. Okay. Now, if we talk about licensing on your ASA firewall, so understand how the licensing is. Your ASA comes pre-installed with the base license. Okay, the base license is already present in the ASA. And then later on, you can install a security plus license as per the requirement. So you can install an additional license, which is security plus license. Okay. So additional time-based and optional licenses can be purchased. So your ASA comes pre-installed with the base license, and then you can purchase additional license from the Cisco. And then you can install these licenses inside your ASA firewall. So when you combine, okay, when you combine additional license to the pre-installed license, this will create a permanent license. Okay, that license will become permanent. And this permanent license is activated by installing a permanent activation key. Okay, so there is an activation key that you'll have to put in, and you will have to use the CLI by using the activation key command. So you'll use this activation key command, you'll put in the permanent activation key, and this will activate your permanent license. So you can install only one permanent license. Okay, and once it is installed, this will refer to as a running license. Okay, so obviously once your ASA is licensed, so that license will be the running license. Okay, so how do you check the license in the ASA? So let's see. Let me just open the EVNG. Everybody is aware about EVNG, right? It's a simulation. So another one. Okay. Okay, that's it. Now, our ASA, it is available in hardware form also, virtual form also. Okay, so we have both the images in the Eve. Okay, the hardware image also is available, and the software image or the virtual image is also available. So I'll go with the ASA. So this ASA is what? This is the hardware image. Okay. Another one I will take the virtual image. This is the virtual image. Okay, so the hardware image needs a license and it is already licensed here. Let me power both of these on. More actions. Start all nodes. Okay, and allow these to come up. So this is the ASA. And now we'll take access to the ASA V. So now we have access to both ASA as well as ASA V. And they're coming up. So allow them to come up. Then after we have to go a little bit of introduction to what are the networks available on the firewall. So we'll talk about inside DMZ, outside. Okay. Then we'll talk about a little bit introduction. Right now I was talking about virtualization feature, then security context, what is different models of ASAV. Okay. What are the different security context mode? What are the features that are not present in the ASAV? What are the different firewall modes? Okay. What are the different deployment types? So all these things we have to discuss. And then finally, we will move on towards the security level concept. Okay. So this much part we'll discuss today. Okay, so coming up, iOS is booting. Post process is going on. Meanwhile, let me open a notepad so that I can share the comments with you as we use them. To understand here, once your ASA will come up, this will be the by default mode. And here, which mode it is? You have gone through CCNA routing switching, which mode it is? Right now I'm available in which mode? Yes, guys, anyone? Which mode it is? Looking at the prompt, you can tell me, right? This is the prompt. That means which mode? How many configuration modes are there? Okay, you don't know, you can just type no. I don't mind that. But please at least respond. So which mode it is? User mode. Okay, or you call it as a user execution mode. Now, if I want to switch to the next mode, which is my privilege mode, I can use here enable command. Okay, and it will ask me for password. Okay, so by default, there is no password set. Okay, remember this, by default, there is no password available on the ASA firewall. So don't try to type down any password like Cisco ASA, ASA. Don't try. Okay, directly say enter and you will be into the privilege mode. Okay, so first thing you need to note here that by default, there is no password set. By default, no password is set. So all you have to do here, don't have to give any password. Then after, if you want to check the license, okay. So what you can do, you can use the command show version. Okay, and this command will show you the information about your license. So you can see that this platform has which license? It has a plus license. Okay, 55520 VPN plus license there is. And this is the running permanent key. Okay, see, this is how the key looks like. Okay, so you can use this command show version, and this command is going to display you the information about your license. Okay. ASA license. So what you do, you can use the show version. So when you use the show version command, what will happen? It will display you about the ASA, what is the OS version. Then it will display you information about the interfaces. Okay, how much RAM is there, what is the CPU speed, what is the flash memory. Okay, other than that, it will give you information like how many physical interfaces can be there. Okay, maximum VLANs you can create, how many inside hosts you can have, failover type. Okay, then encryption, whether -3-AES enabled or not, how many security contexts you can create. Okay, so much of information it is going to give you here, and the validity also, at how long they will be valid. So like clustering 364 days. Okay, security context 364 days, and I can create 20 security contexts in this firewall. Okay, so this is how you can check the license. Now, same thing if you go and check here in the ASAV. Okay, so ASAV, we don't have the license right now. Show version. Okay. So here, if you see, there is no information about the license, and that is the reason that here you can see what is the license state. It is unlicensed. Okay, this is unlicensed, and here you can see the licensing mode. What is the licensing mode selected? So licensing mode selected is what? Smart licensing. So there are two types of licenses. Okay, two types of licenses are there. One is manual licensing and second is smart licensing. So manual licensing is where you put your keys, the activation key, and you activate the license. That is your manual. And smart licensing is what, like you will have a user account. Okay, and with that user account, your license will be associated. So if you log in using that, or if you register your device using that particular email, then you will get the license. Your licensing will be done. That is the smart licensing. Okay, so now let's talk about the networks on a firewall. So on a firewall, you can have inside network, DMZ, and outside. Okay, so inside network, this is the network that is protected behind the firewall, your internal network. Okay, the network that you are trying to secure. So that is your inside, that is your LAN network. Then you have outside, which is not trusted, or you can say untrusted network, the network from where you are trying to secure your internal network. Okay, so this is your LAN network, you can say. Mostly in most cases, your LAN network will be inside and WAN will be outside. So this is going to be trusted. And this one you consider as untrusted. Then you have DMZ. So DMZ is a zone where you keep all your servers. Okay, all your internet facing servers, they will be available in the DMZ zone. Okay, so DMZ stands for demilitarized zone, and this is protected by a firewall. So whether the users are going from inside to DMZ or from outside to DMZ, always they will have to pass through the firewall. So in the firewall, you can configure policies, okay, that will apply to the traffic from your inside or outside network. Okay, so you can filter it out. So limited access is allowed to the outside users. So whenever somebody from the outside will try to access the server, so only limited access. For example, if it is a web server, I will allow communication over the port 80 only. Other than port 80, I will not allow communication through any other port. Okay. So that kind of control we can have. We can give a limited access. Okay. And we can decide that, okay, who is allowed to access, who is not allowed to access. So all those configurations we can do on the firewall itself. So this is clear about your inside DMZ, outside.
Yes.
Okay, great. Now, if we talk about the traffic, that how the traffic flow is in a firewall, so by default, what happens? That the traffic from inside to outside, okay? The traffic from inside to outside, it is permitted. Okay, from inside to DMZ is permitted, and from outside to DMZ it says it is selectively permitted. Okay, and then from outside to inside again it is not permitted. So depending on, this will, these decisions will be made depending on the security level. Okay, what your ASA does, ASA follows the waterfall model. Okay, ASA follows the waterfall model. So we'll talk about this model also. So as of now, you can understand that from my inside, that means this is my trusted network. Okay, so my trusted network, my internal PCs, they are able to access the internet. That means they are able to go outside. Okay, they are able to go to the internet. But from internet, I don't want to allow anyone coming into my local network. So this kind of configuration I can do it. So by default, what will happen, inside to outside, the traffic is permitted. Inside to DMZ also it is permitted. Okay. Inside to DMZ also it is permitted. Okay. So these decisions, these will be based on security level. Okay. So you can consider like the inside, it will have security level 100. DMZ will have 50, and let's say outside will have 0. Okay. So now what will happen, from high security level to lower security level, from higher security level to lower security level, the traffic is permitted, but from lower to higher, it is not permitted. Okay, so this is how the decisions will be made. And we will practically see all these implementation, right? That from outside to inside, it is permitted, from from inside to outside, it is permitted, and from outside to inside, it is not permitted. So all these things practically we will implement by playing with the security level. Sir, what if the security level is same? So if the security level is same for two different zones, okay, for two different zones, let's say for outside also 0, for DMZ also 0. So if the security level is same, or just call it 50-50, anything, if it is same, it is not permitted. There is no communication. In to out return traffic is also permitted. So inside to outside, return traffic will be selectively permitted. Okay, in ASA, the return traffic will be selectively permitted. Okay, that means what? Only TCP and UDP will be permitted. Okay, the TCP and UDP responses will be permitted. Other return traffic will not be permitted. Okay, that is the default behavior of your ASA firewall. Okay, so like if I'm trying to generate ICMP traffic from here, so ICMP traffic will reach here. ICMP ACO request will reach here, but the ACO reply will not be permitted. Why? Because in the return traffic, only TCP and UDP. Connection table made only for TCP UDP for return reply. So yes, by default, okay, there is something called as inspection. There is something called as inspection. So by default, your ASA inspect only TCP as well as UDP traffic. Okay. So once we will allow the traffic, then it will start inspecting. Let's say I can decide that, okay, allow ICMP inspection also. So then my ICMP return traffic will also be permitted. Okay. But as per default behavior, only TCP and UDP. All right. All these things practically we are going to see, that TCP, UDP, how you will enable ICMP inspection. Okay, all these things will become. Then we have your virtualization. So in virtualization, what happens? You convert your single hardware firewall into multiple logical firewalls. Okay. So like this is one single ASA. This is one single ASA. Now what, I have 3 customers Okay, this is my customer network 1, customer network 2, customer network 3. So let's say you can consider yourself, let's say in this scenario, I can say that, okay, I am a security service providing company. So I'm providing firewall services. Okay, I'm providing firewall services to people. So might be that, okay, this is a smaller enterprise, this is also a small enterprise, this is also a small enterprise. So for everybody, I will not purchase a dedicated firewall. Okay, I'll not purchase a dedicated firewall for every single customer. Why? Because if I'll do so, then the organization, I'll have to charge them good, right? And if the organization will have to pay me for a dedicated firewall, so then rather than they can buy their own, they can have it on their premise, right? So with the help of security context, what I can do that rather than purchasing different firewalls for different departments or different customers, I can just have a single firewall, and that single firewall I can divide between multiple customers or multiple departments. Okay, see here the customer scenario is given. You can consider this scenario is like that in my organization, I'm a large organization. I have HR department, I have sales department, I have accounts department. Okay. So to all these three departments, I want that, okay, their traffic, whatever the traffic is going to them. So I want to safeguard the traffic, right? So I can deploy a firewall. So in normal scenarios, if I don't have virtualization capability, I'll have to purchase 3 ASA firewalls. And that will be a very expensive solution for me. So what I can do, I can go with a virtual form of firewall. That means I can create a virtual firewall, or you can say I can create a security context inside the firewall for each and every for each and every department. So depending on the license, okay, depending on the license and model, this can be decided that how many security contexts you can create. So like, the one we have here, this one. So you can see here, okay, this is the ASAV. So in ASAV, we cannot create. Here you can see how many security contexts we can create. So I can create 20 security contexts depending on my license. So now what? That 20 virtual firewalls I can create within this single firewall. 20 virtual firewalls I can create within this single firewall. Okay. So this is how your virtualization concept is. And practically we are going to implement it. How we will see how we can divide uh, the firewall into multiple virtual firewalls. Okay. Similar kind of concept is available in the switches also. What do you call that concept? Where you make a single switch behave like multiple switches. What is that concept in the switches? No idea? Stacking, you combine multiple switches into one. So stacking is kind of similar to clustering. Okay. Stacking is kind of similar to, in ASA, we will call it as a clustering. And your security context, okay, this is where we divide it. So the security context, this is similar to your VLAN concept. Exactly. So with the help of VLAN, what you do? By default, your switch is what? Single broadcast domain. You break the broadcast domain of the switch. You break the broadcast domain of a switch, and now if you have two VLANs, that means two broadcast domains. So this broadcast domain will act as the individual switch. This broadcast domain will act as an individual switch. Okay. So this is how similarity you can understand. This is clear? All right. So what is the security context? Security context is what? A virtual ASA. A security context is a virtual ASA. So that means like one single hardware firewall I divided into multiple logical firewalls or virtual firewalls. So each virtual firewall, it will be known as what? It will be known as security context. So with the help of security context, your ASA is divided into multiple virtual standalone firewalls because each firewall, okay, each virtual firewall, each security context will behave like an independent firewall itself. Okay. So each virtual standalone firewall act and behave as a independent firewall. Okay. So it will be acting as a separate firewall itself. So it is going to have its own configuration. It will have its own interfaces. It will have its own security policies, and it will have its own routing table. And even the traffic will be segregated. The traffic will not mix up. Okay. Any doubt in any of these points? All right. So these are some of the models of your ASAV. Okay. So like depending on the model, we have like ASA V5, V10, V30, V50, and V100. Okay, so depending on the model, they will have the stateful bandwidth like 100 Mbps, 1 Gbps, 2 Gbps, 10 Gbps, and 20 Gbps. And then you know how many what is the VPN throughput, how many VPN connections per second they can have, how many concurrent sessions, how many VLANs. Okay, so all these things they will vary according to the model, and as per the requirement, the organizations they will select any of these firewalls. Okay, sometimes organization might not want to deploy hardware form of firewall, so they will go with the virtual forms of firewall. Okay. So these virtual form of firewalls, you can deploy them in the ESXi and then you can use them. Now, what are the security context modes? Now, by default, your ASA is in the single mode. Okay, so we have two modes. Okay, we have two security context modes. One is single. The second security context mode is multiple. In the single, first of all, this is the default mode, and your ASA will behave as a single device only. Okay, you can create different security contexts when your firewall is in the multi-context mode. Okay, so ASA firewall in the multiple mode, it is like it can split into the desired number of contexts. Okay, and the number of contexts it will depend on the model of the device. So like if you have 5510 or 5515X, you can create up to 5 security contexts. If you have 5585X, okay, so it will support up to 250. ASA 5505, this does not support any sort of virtual firewalls, or there is no security context because this is a very old model. Okay. And even your ASA, it is now almost not used anywhere, but still it is there in the CCA exam. Now, what are the features that are not supported on your ASAV, the virtual form of firewall? Okay, we have virtual image, right? So in the virtual image, what are the features that are not supported? Number one, clustering. You cannot combine multiple virtual ASAs to behave like a single one. You don't have security context mode or multi-context mode. Okay, that means you cannot divide a virtual firewall into more virtual firewalls. Kind of, you can say there is no nested virtualization kind of concept. Then we have active failover. This is also not supported in your virtual ASA. Okay, or the ASA V. Then you have ether channel. Okay, so you cannot create ether channels. And while using clustering, we require ether channel also. And that is one of the reasons that your clustering is not supported. Okay, so ether channels are also not supported, and any connect premium license, that means shared premium VPN license also not supported. So these are few of the features that are not supported on your ASA V. Then what is next? Firewall modes. Okay, so we have two firewall modes here. Okay, one is the routed mode and second is the transparent mode. Okay, so in the routed mode, what happens? First of all, this is the default mode. Okay, for your firewall, this is the default firewall deployment mode. And in the routed mode, your firewall will work as a layer 3 firewall. Okay, in this one, your firewall will work as layer 3 firewall. So if it is working as a layer 3 firewall, you can use it as an edge device. Okay. So you can say it can be seen as a hook, or you can say can be used as an edge device. Okay, you can use it as a edge device. So your ASA firewall in the routed mode, this will act in the same way as a router would. So that means it will perform routing, it will forward the data packets from one network to another network, it will find the best physical path for data transmission. Okay, all those things it is going to do. So also it uses routing protocols as well as the static routes. Okay, so as we have seen that, okay, it is going to work like a router only. So whatever the task router does, same things it will do, like it is going to forward the data packets based on the destination IP address. So it is going to behave like a router only, but with the firewall capabilities. Okay. So this is one mode. Another mode is what? Another mode is transparent mode. Okay. So this transparent mode, this is where your ASA firewall will act as a layer 2 firewall. Okay. So here, like, we cannot configure IP addresses on the interfaces. Okay. So sometimes this is known as a bump in the wire, or sometimes it is also known as virtual wire. Okay. If you are using other vendors, if you're going with other vendors, so this transparent mode concept, it is used as a, or it is known as a virtual wire. Same way your NAT mode, this is sometimes known as NAT, sorry, your routed mode, this is sometimes known as NAT mode, or you can say sometimes L3. And this one, sometimes it is known as L2 or virtual wire. This is NAT or L3. And since it is working as a layer 2 device, it has nothing to do with the IP addresses. So you cannot use it as an edge device. Okay, so that means it will not be seen as a hook. Okay, so you can say here this cannot be used as a edge device. And here, as a switch would do your ASA firewall in the transparent mode, it will forward the frames based on the destination MAC address. Okay, it will make forwarding decision based on the destination MAC address. So these are the differences between your routed mode and transparent mode. Is it clear? Any doubts between the routed mode and transparent mode? Yes, guys, any doubt, please let me know. All right. Looks like this is clear. Now let's see how you can check between, how you can check the modes of your ASA firewall, like how you can check the security context mode, how you can check the firewall modes. Okay. These things we will see. So here, this is one thing given that these are the possible modes of your ASA. So you can have like firewall mode routed, you can have, which is by default, and security context mode single. This is the default configuration. Okay. But you can have, if transparent mode do forwarding based on destination MAC, then it will also drop first packet due to encapsulation failure. See, in transparent mode, your firewall will act as a switch only. You can say kind of a switch with firewall capabilities. So if you have two PCs, okay, if you have two PCs that are connected with a switch, okay, two PCs that are connected with a switch. So will there be any packet drop due to encapsulation failure? Let's say this kind of situation. PC, you have a switch. Again, you have a PC. Here I have given, let's say 10.1.1.1, 10.1.1.2. MAC address M1, MAC address M2. So if my PC1 tries to ping 10.1.1.2, this is PC1, this is PC2. So will there be any packet drop? Yes or no? No. Same way, when your firewall is in transparent mode, in that case, there will be no problem because it is acting as a switch only. When it is acting as a router, then packet will drop. In that case, packets will drop. Yeah. Clear, right? Okay. So we can keep the routed mode of the firewall and we can change the mode to multiple. From single, we can keep the transparent mode. In the transparent, it can behave as a single firewall. In the transparent itself, it can behave as a multiple firewall also. Okay. So that means we can have the multiple mode in routed as well as the transparent, both the modes. Okay. That kind of deployment also we can have. Then security levels. So we'll come to the security level. First, we will check all these modes. Okay. The routed mode and off. So there is a firewall. See, if I give the command show firewall, okay. If I say show firewall, so what is my firewall mode? Right now, my firewall mode is router. Okay. So if a firewall, so how you can check? You can give the command show firewall, and this will tell you that by default, the firewall mode is what? It is router. Now, if you want to change the mode from router to transparent, okay, if you want to change the mode from router to transparent, so how you are going to change? Okay, so what you'll do? You'll give the command here, firewall transparent. You'll give the command, sorry, mistake, and it will be in the global configuration mode. Okay, you'll give the command firewall transparent, firewall transparent. Okay, so now what will happen? Now if I will give the show firewall command, okay, here we don't have the do command concept. Like in your routers, what happens? That if you want to execute any privilege mode command or if you want to execute the show command in the global configuration mode, then you have to use a do. You have to append a do in front of the command. So on ASA, we don't have the do command. We don't have the IP command. Okay. So now if I say show firewall, you can see that firewall mode is now transparent. So this is how you can change. Go here. Change firewall. So if you want to change the firewall mode, you can use this command. You can say firewall transparent. And what it is going to do? It is going to change your mode to transparent mode. Now remember, whenever you will set the firewall mode to, like whenever you will change the firewall mode, so that time what will happen? Your running configuration will be lost. Okay, your running configuration will be lost. So here, let me give you a note that when firewall mode is changed, then let me go on actually. So when the firewall mode is changed, firewall mode is changed, running config will be lost. Okay, so you are going to lose your running configuration, but if you have your backup in the startup configuration, if you have already given the startup configuration, in that case, what will happen? That your startup configuration will not be lost. Okay. What is that error? This error says password recovery was not changed, unable to access the configuration register. Okay, so this is just something related to password recovery. You know, in the router also, whenever you want to, you can say you want to perform the password recovery, then you have to change the registers. Okay, you have to change the registers. So that is what it is saying here, that your password recovery register was not changed. So if you want, you can use the same thing here. You want to see 2102, it will check for the NVRAM, and 2142 that will bypass the NVRAM. So right now we are not able to set it for some reason. That is something with this iOS only. Okay. As of now, just consider this thing. Okay. I'll check this thing that why we are not able to set, and then I'll check. Okay. So it is nothing related to your firewall mode. It is just about the, okay, we are not able to set because I believe we are in the transparent mode. So first let's go back to your, we'll go back to your router mode. Okay. So when you want to go back to the router mode, what you will do? You will say, you will not say like firewall router. No, you will say no firewall transparent. This is how you will give it. Now if I check show firewall, now I'm back to the mode router. Okay. And if I say register 2122 0x2, I'll check it why we are not able to set. Okay. So right now what you need to understand, see here, that the firewall, whenever you change the firewall mode, your running configuration will be lost, and startup configuration will not be lost. Okay, you will not lose your startup configuration. Other than that, your ASA will also not start. Okay, like your ASA device, it will not restart. It will just change the mode. It is not going to restart. So as I'm saying that your running configuration will be lost. Okay, so if you ever plan to go back from your, transparent to router mode, in that case, you must take backup of your running configuration before changing the firewall mode to transparent. Okay. And this is applicable for both the scenarios, whether you are changing from router to transparent or transparent to router. If you are ever planning to come back to the same mode, then make sure to take a backup. Okay. So that also let me mention here that if you are planning to back to the same mode, then take a backup of your running configuration. Because every time you change the firewall mode, your running configuration will be lost. Okay. So take a backup of your running config before changing the mode. Okay. And if you want to go back, in that case, what you will do? You will use this command. No firewall transfer. This is how you will switch back to the original mode, which is the default mode router. So this is how you will change the router mode. Okay. Now, if you want to change the security context mode, okay, if you are willing to change the security context mode, then how you will change? Change security context mode. Okay. So yes, a firewall modes. We have two modes here. There are two firewall modes. Okay. One of the mode is router, which is the default, and number two is the transparent. Okay. So in the router mode, your device will behave as L3, and in the transparent mode, it will behave as a L2, like a switch. Okay. So before checking the firewall mode, this is how you check the firewall mode. All right, so this is done. Now let's talk about the security context mode. So security context mode, again, we have two security context mode. There are two security context mode. Number one, single, which is by default. The default, and here ASA behaves as a single device. Okay. And mode number two, which is multiple, which you have to change. Okay, so in this ASA behave as a multiple device. Multiple virtual firewall. Okay, so how you are going to change, or first of all, how you are going to check the security context mode? Security context mode. Okay. So if you want to check the security context mode, you will give a command show mode. So right now you can see the mode is single. How you will check. Now if you want to change the security context mode, in this case, what will happen? You will say, let's say right now it is in the single mode. You will say mode. So you can give the command mode multiple. Okay, and this will change. So proceed, just proceed. It says the command will change the behavior of the device. The command will initiate a reboot. Okay, then change the mode. So I said yes. It is saying convert the system configuration. So it will convert the single mode configuration into multi-mode configuration. Say yes. And you see my device is restarting. Now allow it to come up. So we use the command this is how you will change. You will use the command mode multiple. So post process is going on. Now in this case, your configuration will not be lost. Okay. In this case, your configuration is not lost. Now if I say show mode, so you can see my mode is what? Multiple. And if I want to go back to the single mode, okay, so I'll not say something like no mode multiple. No, here this time we will say mode single. Okay. So here I'll say configuration tablet and I'll say mode single. Okay. Again, the same questions it will ask and it will repeat. Okay. So here note and mention that if security context mode of ASA is changed, the configuration will not be lost. This time the configuration will not be lost. And if you want to change that, this is how you can use it. Once this will come up, then we will start understanding about the security levels. Although we have already understood, but some part that we'll discuss, we'll design the lab. Okay, so this is already up. Now I can check. Show now. So now I can see that the mode is what? Single. So this is how you can change the firewall mode and security context mode. Any doubt in this part? All right. Now let's first do one thing. Let's set up the lab, that how your ASA practice lab is going to be. And for a while, we will be using the same lab. So let me power off these devices. Okay. Initially, we can go with the ASAV image, not a problem. Okay. So what I'll do, I'll take a ASA firewall here. Okay. This is the ASA I have taken. Now, on the inside, I'll take one router. See how our lab is going to be. First of all, let me draw the topology so that you can understand. So I'll use the inside router here. Okay. And we'll use, let's say, one more router. And one inside PC I will use as a client. Then we will have a switch to which all these are going to be connected. We are going to have our ASA firewall. Then one more switch will be there. On the outside, I'll use two routers, 1 and 2. Okay, one router I will use on the DMZ side, and one admin PC I will use for the management. Okay, so this is how our lab scenario is going to be. And for a while, we will be using this lab only. Okay, we'll be practicing all the concepts in this lab. Then once we are into the interface level payloads, HA concepts, okay, security context and all, in that scenario, we will design different labs. Until then, we will be using this lab only. Okay, this is how it is going to be. This is your ASA switch. This is going to be our inside R1. This one is going to be inside R2. This is our inside PC. This will be our DMZ server. Right switch here. This will be outside switch. This is going to be the management PC, you can say, or admin PC, same thing. Either admin you can say or management you can say. This is our outside R1. This one is going to be outside R2. So this is going to be our inside zone. This will be our outside zone. This will be DMZ. And this one is going to be management. Okay. Consider the interfaces of the ASA. So let's say this one is the 0 by 0. This will be 0 by 1. This one is going to be the 0 by 2. This is going to be the 0 by 3. So on the inside, we will use the network 10110/22. Okay, this is the network I'll be using here on the inside. On the outside, I'll be using 11110/22. On the management side, I'll use 10.3.3.0/22. On the DMZ side, I'll use 10.2.2.0/22. Okay, so this inside R1, I'll use the IP 10.1.1.125. Here I'll use 10.1.1.126. Here I'll use 10.1.1.5. And on the ASA, I will use 10.1.1.10. This side 11.1.1.10. Here 11.1.1.125. Here I'll use 11.1.1.126. Then DMZ server 10.2.125. And on the ASA, on the DMZ side 10.2.10. On the management side, ASA will have 10.3.3.10. And the PC, the management PC, we can say that 10.3.100. These are the IP addresses we are going to use. So this is how our lab setup is going to look like. Okay. So we need 1, 2, 3, 4, 5 routers. 5 routers, 2 switches, and 2 PCs. All right. So I need 5 routers. Let's see. Okay. So this will be inside R1, inside R2, DMZ, outside R1, outside R2. Then I need 2 switches. So I'll take 2 switches. So this is my inside switch. This is my outside switch. Then I'll take 2 Windows PC. Okay. This one on the management side. Okay. And if I want, I can use my local PC also, this PC also as a management. Okay. So this is how our lab setup is going to look like. Let me make the connections. So this one will be C0 by 0 interface of the ASA. This is going to be Z0 by 1. This is going to be Z0 by 2. And this is the management interface. So I'll select here management. And then this is connected here. This one is connected here. This is connected. Connected here. And connected. Connect this side. Now this is, we are going to name it as inside R1. And we are going to name it inside R2. This one I'm going to name it as client PC or inside client. Let's name it inside PC. This is DMZ server. This is your inside switch. This is your management PC. This is the outside switch. And then after we have outside R1. And this one is outside R2. Okay. Now this is how the lab will look like. And now about the IP addresses. So let's mention all the IP addresses also. So inside network will be 10.1.1.0 last 24. So this is my inside network. And then on the outside, I will have 11.1.1.0 last 24. This is the DMZ one. In the DMZ side, I will have 10.2.2.0 last 24. And on the management side, you will have 10.3.3.0 last 24. Then on the inside R1, we will have our IP address 10.1.1.125. Here we will have the IP address 10.1.1.126. And then on the inside PC, you will have, let's say, 10.1.1.5. Then On ASA, on the inside interface, we are going to have here 10.1.1.10. And then here on the DMG side interface, we will have 2.2. And DMG server IP address will be 10.2.125. On the management side, on the ASA, we will have 10.3.3.10. And on the management PC, let's say you have 10.3.3.100. On the Z0/2 interface, we will have 11.1.1.10. This will be 11.1.1.125. This will be 10.1.1.126. Then I can just lock the lab and we can power up all the devices. So the lab scenario is clear, how the lab will look like. Yes or no?
Sure.
All right. Now all these devices are coming up. This is inside. Already few access is there. Yes, inside router 1. Inside router 1, inside router 2. DMZ. Outside router 1, outside router 2. Okay, then you can take access of your inside PC also, as well as the outside PC also. Okay, which is the management PC. So this is your management PC here. This is your inside PC. So let's go and set up the IP addresses here. Password is test123. Here also test123. Test123. Start later. Open the network configuration, and in both the places, I will set up the IP address. To local area connection, right now there is no IP address available here. Properties and TV4. Then this is inside PC, so 10.1.1.5. Subnet mask 255.255.255.0. Gateway will be what? ASA IP address 10.1.1.10. Say okay. Okay. Good. Same thing here. Just go to the configuration, say the following IP address, 10.3.3.100, 255, 255, 2550, 10.3.3, 10. Okay, so let's check. All right, close. So here we have set up the IP address. Now it's all about the basic configuration of all these devices. Okay. So let's go and do the basic configuration. Let me open another laptop. So what you'll do, first of all, let's do the configuration for inside R1. So I'll say enable configuration terminal. Then I'll say hostname, and hostname is inside R1. Interface Z0 by 0. IP address 10.1.125, 255, 255, 2550. No shutdown. Okay. Then after, I will also enable telnet SSH, and I will give a default route on this inside so that I can reach the other networks. So I'll say IP route. So my default route will point towards 10.1.1. Now let me enable telnet SSH also. So I will say username, Facebook, privilege 15, password, Facebook. Then I'll say line VTY 024, login local, transport input, telnet, or let's say all, because I want to configure SSH also. So to configure SSH, I'll say IP, domain name cisco.com. Then I'll say crypto, key generate, RSA, modulus. Let's say 1024-bit keys I want to use. Then I will enable HTTP also. So I'll say IP HTTP server. Okay. Then if I want, I can enable HTTPS also, IP HTTP, secure server. Okay. And for HTTP authentication, I'll say IP HTTP authentication local. Okay. From the local database, I want to authenticate the HTTP user. So I have configured telnet SSH, HTTP, HTTPS here. Now same configuration I will paste for R2 also. Now for R2, inside R2, this is inside R2, IP address will be 126. A route will point towards 10.1.1.10 only. Now this is fine. Okay, so R2 configuration is done. Now DMZ server configuration. Same thing, hostname I will give. Then I'll say that here the IP address is 10.2.2.125, and the route will point towards 10.2.2.10. Remaining all the configuration will remain same for SSH, telnet, and SSH. Sorry, for telnet, SSH, HTTP, HTTPS. Now I have to do the configuration for what? Your outside routers. So let me copy this configuration. So this will be outside R1. So same thing will be the host name. This will be 11.1.1.125. This will be 11.1.1.10. And remaining configuration will be as it is. Then I will have outside RT. Outside R2. 11.1.1.126. This will point towards 11.1.1.10. Remaining everything is okay. Okay. So if you see, we have done the configuration for management PC for the inside PC, and now we will do the configuration for the routers. So let me access one by one. This is inside router. I would say no. Okay, same thing here. Say no. Say no. No. Okay. Now I'll copy the configurations. This is inside router 1. Copy. Paste. This is the configuration getting pasted. Okay, so there was no error generated. I'll say do write to write the configuration. So that tomorrow when we will start the lab, we will have this configuration. We don't have to do the entire configuration again. Copy. And now this we will paste in the output. This is getting pasted. Go to the DMZ server. And here, DMZ server. Then outside R1. Go to the outside R1. And the outside R2. Copy. This is the outside R2. Okay. Everywhere we will write the configuration. So these configurations have been written. Now, as of now, we will not have communication from inside to outside, inside to DMZ or inside to management. This communication we will not test because we have not done any configuration for the ASA yet. Okay, so what I'll do, first of all, I will test connectivity on the inside, on the outside. Okay, these two connectivities I will test. So let me take access of my inside PC. Inside the inside PC, I'll test communication. I'll say ping 10.1.1.125. So I have the communication. So that means R1 is okay. inside R2 is also okay. So we have the communication. Okay. Then here on the outside R1 and R2, I will test the connectivity. So from outside R1, I'll go and try to ping outside R2. So I'll say ping 1111 126. So we have the communication, you can see. I have the communication. So far our configurations are totally fine. No any issue. Now what next we have to do? We have to go and configure the ASA. So the ASA configuration about the security levels and all that with what name, what security level, how you will assign the IP address to the ASA interfaces. So this part we will cover tomorrow. Up till now, any doubt? Clear? Okay, so today you guys set up this lab. So tomorrow we can start with the practical. Okay. So anyone who has not received the access,